Good afternoon, everyone. It's my pleasure to welcome you to our second Answer ALS webinar. My name is Emily Baxi. I'm a neuroscientist at Johns Hopkins and also the program manager for Answer ALS. Today, I'm delighted to be joined by Dr. James Beiwe. Dr. Beiwe is a neurologist and clinical researcher at Mass General Hospital and also a principal investigator for the Answer ALS clinical program. Today, we're going to begin with just a very brief overview of the program so that those of you who are perhaps less familiar with it can get an idea of our goals and strategy. Then following a quick update on our progress, we'll move to our topic for this webinar, which is using technology to answer ALS. Big data and technology are really key components to multiple aspects of the program, but for the purposes of today's presentation, we're going to focus on a piece of technology that I know is near and dear to many of us, the smartphone. Just a moment, Dr. Beiwe will tell us about an app that was custom designed to monitor ALS symptoms from a smartphone. We hope you find the webinar informative and interesting, and I encourage you to ask questions at any point using the chat function. We will answer as many as we can at the end of the presentation. Okay, so what is Answer ALS really about? Our mission is to build the most comprehensive clinical and biological assessment of ALS in history so that researchers and scientists across the globe are equipped to understand and ultimately end ALS. I'm going to stop for just 1 second. I realize people are having some issues with slide sharing and seeing the screen, so I'm just going to try and correct that, but bear with me for just 1 moment. Okay, hopefully everyone can see our mission statement now. So, as it says there, our goal is really to bring personalized medicine to the ALS community. And how do we go about doing that? Well, today we recognize that patients, although they may have the same clinical diagnosis, be it ALS or breast cancer or any other disease, they may not all be the same. And because of that, one group may respond very well to a treatment, others not as well, and some may be more prone to adverse effects than others. Each of these subgroups may require a distinct approach to the management and treatment of their disease. So the key to personalized medicine is that we find some way to recognize these subgroups. The goal of Answer ALS is to build a library of knowledge that will help researchers and clinicians to identify subgroups of ALS, so we can then find the most effective treatment for each individual with ALS. So the Answer ALS research program was designed to take an in-depth look at both the clinical and biological features of 1,000 people with ALS and 100 controls. Each participant is followed for about a year at one of our 8 clinics. In between clinic visits, we also follow disease progression using the Answer ALS app, and that's what Dr. Beiwe will tell you a lot more about in just a moment. Then to assess the biological features of ALS, we take samples of blood from each participant and run a number of tests, including whole genome screening at the New York Genome Center and multi-omics analyses of stem cell-derived motor neurons. Cells isolated from blood can be converted into pluripotent stem cells and eventually motor neurons, which, as you know, are the cells that are affected in ALS. We then run in-depth biological analyses on these cells to understand how their expressions of genes and proteins may vary from healthy controls and indeed from other patients with ALS. All of this information will be assembled in a data repository that we will then make available to the global research community. Once that library of information is amassed, the next phase is really about big data analytics and employing machine learning to begin to uncover ALS disease subtypes. As I mentioned, we have 8 clinical sites around the country: Massachusetts General Hospital, Emory, Johns Hopkins, WashU, Ohio State, Cedars-Sinai, and most recently we were joined by Northwestern University and Texas Neurology. And each of these sites has done a really terrific job enrolling and caring for our participants over the past couple of years. Okay, it looks like we may be having issues with the screen share. Let me just correct that again. Okay, so hopefully that doesn't continue to happen, but thanks for your patience, everybody. Okay, so I told you I wanted to just give you a brief overview of our productivity over the past couple of years, and the good news is that Answer ALS has been doing really, really well. As of yesterday, we have enrolled 855 participants. So the trial from a clinical standpoint is actually just over 85% enrolled. Wonderful. We also track the follow-up visits at each site, and where possible, we ask that participants return for a total of 5 visits over the course of about that year. And you can see from this graph that we have pretty good patient retention over the course of that time, with many patients having completed all 5 visits at this point. We have also been amassing a biorepository. So this is a large library of samples taken from ALS participants that we are making available to the global research community, so that both amongst our consortium here at Answer ALS and beyond in the global research group, we can actually avail of these samples and incorporate them into valuable studies that we hope will be conducted in the future. These samples are all available through the NEALS Biorepository. We are also making excellent progress with the New York Genome Center. They have received about 500 samples from our clinical sites and have sequenced the genomes of 372 ALS participants so far. And we were very proud to participate in a collaboration with Project Mine at the New York Genome Center, and some of these genomes actually contributed to the identification of KIT5A, which is a novel gene associated with ALS. So we are also already making something of an impact in the community. Over the past year, our science teams have worked diligently to optimize the protocol for motor neuron differentiation and to capture as many ALS features within these cells as possible. If you remember, you really can't take a biopsy of a participant's brain or spinal cord without doing irreparable damage. So recreating these motor neurons outside of the participant through the use of stem cells is really a key component to Answer ALS. And it allows us to interrogate at a much deeper level the pathways and processes that may be perturbed by ALS. So the stem cell team at Cedars-Sinai has done a wonderful job. They've processed 821 samples over the past couple of years and have already established 322 unique ALS lines. In line with our general mission to share all of the data and resources that we're generating through Answer ALS, we're also making these lines available through the iPSC core at Cedars-Sinai. So right now, researchers can go online and look at a database that tells them about details of the lines that have been produced and select those that may be most applicable to their study or area of interest. So that's just a very brief update on the wonderful progress that our team has made so far. I will stop there and hand over to Dr. James Berry, who's going to tell you a lot more about the app and the application of technology to Answer ALS.
Can you hear me? Great. So thank you so much, Emily. I'm going to talk a little bit about how we're working technology into the Answer ALS project. This is becoming a really important part of the project, and I think a really exciting part. Next slide. Thanks. So one of the reasons that we began to sort of work on the technology piece of the Answer ALS project is that we really need a detailed way to characterize each person with ALS, because the disease onset and course is unique to each person. And so our monitoring tools really need to respond to that. We need to be able to capture the richness of what's happening with a very rich data set that we can capture. And I would go beyond that to say, a rich data set that we can analyze, because capturing data is one thing, having a way to analyze all that data is another really important thing. Up until now, we've used tools like the ALS functional rating scale, which is very informative, but it really kind of treats every person as though they're essentially the same. And then sort of, we have these domains, bulbar, respiratory, fine motor, and gross motor, and we try to fit people into that pattern and sort of, fit them to the tool. I think what we want to do with technology is be able to fit our tool to the richness of each person. Next slide. So in the consumer world, kind of technology and medical technology, things that we can apply to medical technology is already here. So we have very sophisticated ways to communicate with one another in the form of FaceTime, Skype, and texting. And this is only now making its way to the medical world. And beyond that, we also have ways of capturing digital information about ourselves, about our activity using a watch or a wearable, about our temperature, about our body weight. And these things really are blossoming in the consumer world. Next slide. Adoption of technology within healthcare has been slower, and there are a number of reasons for this. So one is that privacy. I mean, I think we have an obligation to really treat medical information with a high degree of privacy that isn't really doesn't need that kind of attention in the consumer world. And there are also, I think, stricter laws in the medical realm that we need to negotiate. And there are also a lot of regulations. And I think there's a culture of sort of doing no harm, which permeates everything that we do. And sometimes I think in the medical world, if we have a way to monitor things that's been working for some time, we're reluctant to give that over for a newer way to do things because of the risk that the new way may not work. And the final thing is some of the endeavors using technology can be expensive, but I would counter that by saying I think there's also cost savings to be had as well. Next slide. Just to give you an example of sort of what this looks like, an early piece of medical technology was the stethoscope. And, this was a sort of a story that we see being recapitulated now. In 1812, René Laennec invented the monaural stethoscope. It was essentially like putting a toilet paper roll up to somebody's chest and listening to their heart. And it was better than putting your ear against the chest, which is what doctors used to do up until that time. But it was criticized for sort of being a tool that came between the doctor and the patient. It was eventually adopted in 1851, the kind of more traditional stethoscope with one listener for each ear, so to speak, was invented. But even that took about 50 years to be adopted because there was concern that somehow this would cause an imbalance between the ears and confuse the physicians, and they wouldn't be able to hear the heart sounds. Obviously, that was not right. But it just is an example that, throughout time, this adoption of technology has been slow, and I think it's something we have to be aware of and try to work to change. Next slide. In Answer ALS, we have a commitment to innovation. And the truth is that using technology to measure and monitor ALS progression is untested. It's uncharted, it's unvalidated, it's uncertain, it's potentially unreliable, and it could make people uneasy. Those are all things that are true. Click ahead. So I think the question is, why do we add tech to Answer ALS at all? Why not have this kind of, theory that, we really shouldn't look to these things because there are potential downsides? And of course, the answer to that, next slide, is that, with this technology comes hope that we can do things better, hope that we can move trials along faster, hope that we can get to a cure more rapidly and more efficiently. And I guess I would say if we're creating this forward-thinking project, which I think Answer ALS really is, we really can't spend all our time looking backward at how to do things most reliably without taking some chances on how to do them better in the clinical realm as well. Next slide. So what we need to do is move from our traditional outcome measures or traditional ways of tracking disease progression or understanding people with ALS to incorporating tech to also tell us something about people with ALS and the disease progression and act as outcome measures. And so that's what we're going to do in Answer ALS. Next slide. So just to give you a sense of where we're starting, the traditional outcome measures that we work with are the revised ALS functional rating scale, or ALS-FRSR, that I think most people are familiar with. It's a 12-question questionnaire. Each question is scaled 0 to 4, and the total scale is 0 to 48 points. It tells us about respiratory function, about bulbar or speech and swallowing. It tells us about gross motor, and it tells us about fine motor. We also look at vital capacity, which is essentially having a person take a deep breath and then blow into a device which can tell us the total volume that they exhale. We look at quantitative strength testing, which is essentially saying how many pounds of pressure can each of the muscles that we test generate. And those are clearly relevant. We also look at survival. Those are relevant, and they're important. I would say that there's a very substantial hole in our traditional outcome measures, and that is that we really don't have a standardized, objective bulbar function outcome measure, something about speech and swallowing. So we're really essentially blind to that. There are a couple of questions on the ALS functional rating scale, but we're essentially blind to that very important piece of this disease. So I think when we think about how we translate what we're doing into technology, it's not just taking what we're already doing and putting that into a digital package, but rather thinking about how we can fill in some of the holes as well. Next slide. So the other thing that we need to think about is how and when we collect our sort of traditional data about ALS and about outcome measures in trials and in Answer ALS. So many trials involve monthly visits. Click ahead. So if you think of these dots as sort of each of a monthly visit, they vary a bit. And if we miss one of those 6 visits over, say, a 6-month trial, we're missing almost 20% of the data. And that really threatens the data integrity of the entire trial. And it's really just one missed visit per person. Next slide. In Answer ALS, we have even an additional problem, click ahead, which is that the visits are every 3 months. And so if we miss, click ahead one more time, if we miss one of those visits, then over a 6-month period, we only have one measurement. And that's because Answer ALS is really meant to be accessible to a broad group of people with ALS. So we tried to time it along with essentially clinic visits. And there's a lot of leeway in those visits. So I think there's a very good reason to have it designed this way. But we have to think a lot about what missing data does to our data set. Next slide. Turning our attention to where we want to go, thinking about tech-based ALS outcome measures, we want to characterize a person's behavior by analyzing some digital signal from technology. Click ahead. There are 2 ways to do this. One is something we call passive data. That is data that's taken from sensors, including, say, for example, a GPS or an accelerometer, but there are other sensors in a phone, a magnetometer, etc. And a lot of this is coming from a cell phone, so we can just put an app on a phone and let people go about their daily business and sort of use their phone the way they do and get a lot of data, though there's a certain amount of variability that we need to contend with. The other way to collect data is what's called actively collected data, and this is essentially surveys and tasks. You might have an app on a phone or a wearable, but you're asking participants to go out of their way and do something different for the study. And that can be a very powerful way of collecting data as well, because it's a more constrained environment, less variability, you can get exactly the information you need, but people need to remember to do it. Next slide. So probably there's some combination of this, but whether we use passive data or active data primarily, using mobile technologies, we can get nearly continuous or at least daily data collection, which gives us a very rich data set, and probably higher variability as well. But that's something that I think we'll learn about, and having the more frequent monitoring will be able to let us overcome some of that variability. Next slide. So I'll tell you a little bit about a pilot project at MGH that sort of was preceded Answer ALS, and we're still analyzing the data. I'll cut to the chase because it's a lot of data, but it taught us a lot about how to approach technology in ALS. And this is an app that was developed at the School of Public Health here, and sits on the phone and essentially collects information from the sensors periodically and sends that to a secure medical server on the web, and then feeds into a series of algorithms that allows us to digest those huge amounts of data into kind of meaningful data points. And I'll show you some of that data in just a minute. Click ahead a few times, Emily. So the app collects passive data from sensors, also an ALS-FRSR and audio recordings. And we've enrolled 23 people in this. We have a huge amount of data from them, and analysis is ongoing, but I'll show you a little bit of interim analysis. Next slide. I don't want to spend too much time on this slide, but essentially we are getting some of our traditional measurements throughout the study at week 0, 12, and 24, and a kind of a phone call at week 6. And then we're also getting weekly voice recordings in ALS-FRSR and even a cough, and pulling passive data from the sensors in the phone. Next slide. So one of the first things that we looked at is a very simple question that really has not been answered before, which is, if we let people answer questions about the ALS functional rating scale on their phone, how does that correlate with what we do in clinic? We've only analyzed 10 of the participants for what I'm showing you here, and I'll tell you that it's probably not the cleanest statistical analysis, but there's a very high correlation between self-administered ALS-FRS and the in-clinic ALS-FRS. The R value is 0.93, which just tells us that they're nearly the same. There is a bias toward a little bit higher score, 1.5 points or so, when people do a self-administered ALS-FRSR, and it probably has to do with interpretation of the questions. I'll tell you that we've looked at the whole set of 23 participants in a slightly different, probably more robust statistical analysis using just a single time point from each person. Our correlation is exactly the same. The skew is a little bit more, so there's almost a 2-point difference, a little bit higher when people enter their own data. That's important that we know that. It's overcomable and understandable. It's just important that we characterize it. Next slide. We've also looked at the average daily distance traveled by people using GPS data from the phone, and this seems to decline over time in essentially all the participants over a 6-month period. Next slide. And this is, I should say, just a subset. And again, in that same subset of 10, we've looked at pauses in speech. So there's a passage that people read, and we take the total time that they're reading and say what percentage of that time is pausing and what percent is reading time. And we can get a little more sophisticated than that and take out some of the pauses for grammar. We have algorithms to do that. And what we can see is that in general, there is an increase in pause time within speech over time. And that may be the first really reliable marker of bulbar progression. And this is recapitulated in more sophisticated in-clinic studies. So there's a high correlation with what we've seen in clinic using this sort of mobile app. Next slide. I won't spend too much time on this. This is something that we're still working on, but there are ways of analyzing the data from the accelerometer to look at approximate when people are sleeping. So in this graph of white and black, and a little bit of red and blue, I guess, right in the middle, that all that white space in the middle are times when the accelerometer is not showing any movement. So all the little boxes on here are are coded either black or white. Black means there's movement of the phone, and white means there is not. Everything is shifted, so the nighttime is kind of in the middle of that figure. The blue dots are sort of estimated sleep onset. The red dots are estimated wake onset. It's an estimate. It's approximate. As I said, we're still working this out, but it is interesting that we can kind of pick out behavior in this way by just looking at the accelerometer. Next slide. At this point, when we're launching into these technology projects, we're really looking at kind of four main things. One is feasibility. Do we have the technology to roll out a new way of sort of digitally monitoring people? And what are the logistics of that? How do we deliver it? And what's the variability? Is the data any good when it comes back to us? And then what's the satisfaction like? What is that user experience for people with ALS and their caregivers? And also, what is the satisfaction on the researcher side? How usable is it for incorporating it into research projects? A third thing is resource utilization. So is it an efficient use of people's time? What we don't want to do is sort of trade, clinic measures that work pretty well at monthly clinic visits for something that is undoable at home, because that's not a step forward, that's a step backward. But I think there should be a way to do this very efficiently, and we want to keep a close eye on that. The other thing is just looking at reducing study staff time, which makes our trials cheaper and would potentially allow us to do more of them. And only after really we've assessed those things can we really begin to understand the effectiveness. Can we monitor fine motor function, breathing, speech, and mobility? And that's really what we want to get at. So we're doing a lot at the same time with these early studies in tech and ALS. Next slide. So for the Answer ALS app, we really created this over a period of time. And it was born out of a collaboration with the developers at Johns Hopkins and the Kata Design Studio and the Brain Learning Animation and Movement Lab, or BLAM Lab, really led by Omar Ahmed and Promit Roy, who did really just an excellent job on the technical side of this, turning our sort of vision and sort of what we wanted to do into a really wonderful app. Bringing to this team, we also brought different things to this team. We had some clinical experience with ALS tech projects, obviously a lot of experience with study design and outcome measures and what we needed to do. And I think a very practical measure of how we translate our traditional outcomes to technology-based outcomes for ALS, but really not a good idea on the clinical side, not a good idea of how we actually turn that into an app. And the Kata team really have a lot of extensive experience with med tech. Many of them came from industry where they were, working at a very high level, developing apps and understanding user experience. And so there was this intense focus on interface and usability and security and data management, all the things that make that app successful. Next slide. So in the end, we came up with a design for this app that has 7 modules. It's focused primarily on active data collection. That was a decision, because this is probably gives us the data that correlates best to sort of our traditional outcome measures and makes us take a step toward technology and gives us the most useful data right now. And so there's some really exciting things that we built in. There are 7 modules. Each module is meant to be done, 1 per day, and they can be done really quite quickly. The first module is voice recording. I'll speak about it in a little more detail on the next slide, but there are 3 different tasks within that one that sort of rotate week by week. Modules 2 through 6 are fine motor function, and they really amount to sort of tracing tasks, tapping, and manipulating the phone. And we have some videos to show you about those. The modules repeat each week, so that every day is different within a week, and then they start over for the next week, and that gives us a detailed understanding of each of these tasks over time, hopefully varying things for people. This detailed data is going to provide new insights into function. So first of all, it's more frequent data collection than we've ever been able to do before. Second of all, there's a timestamp on these, so when people complete a task, we can know when that is. And that because that'll vary, just depending on what people are doing in a day and when they decide to do this, that will give us an exploration of function over the course of a day that we really have never been able to do before, because it's always, during a study visit, the vast majority of which happen late morning, early afternoon. So we've really had a window into a very small part of the day in the past. And the other thing is that these are highly quantifiable outcome measures, even much more so than our traditional outcome measures, which are an attempt to take clinical observations and turn them into some quantity we can put in a clinical trial. Next slide. So now we have a series of videos where we can show a little bit about how to do each of these tasks. So this first task is a tracing task. And within that, there are a few different tasks. The video is a little jerky, but this is somebody who's really remarkably good at these complicated, difficult tasks. So that's the tracing task, and we have one for the right hand, one for the left hand. Next slide. We'll go on to the next task. So the next task is a tapping task. So there's a target, and then people are asked to tap on that target. They complete that tapping, and there's a different target. People are asked to tap on that target, and then there's another target. And the targets are varied in size, so that we can look at accuracy, speed, and potentially even pressure. Next slide. Thanks. So the last one is manipulating the phone, and this is using the gyroscope in the phone to really trace along a pre-existing line, but do that by manipulating the phone to keep a dot along that, move a dot along that line. These are not easy tasks, nor are they meant to be easy tasks. And we certainly don't expect that they'll be perfect by any means. There is probably a learning effect, and so one of the things we have to understand is sort of how to incorporate that learning effect into our analysis. So when people do this more than once, they get a little bit better at it. But that's something that the folks at CADA and the Bland Lab have a lot of experience analyzing from some of their other projects in medical technology. And on the next slide, you'll see that there's a task that's called for, and the person can decide not to do that task, because sometimes you just, you want to sort of acknowledge that you've looked at it, but it just isn't the right time to do it. And so it's important, that people can do that. It's marked as done, even though people have chosen not to participate in that task, and that's okay. Next slide. The only thing I would point out is that task that we're demonstrating can be declined is one for voice recording. And this is, I think, a really important piece of the Answer ALS app, because speech is really a complex motor act. And this is a slide from Jordan Green, who's a speech and language pathologist researcher here, who's done a lot of work in motor speech control in ALS, and really divides speech very nicely into four kind of categories. There's a respiratory category, how loud is your voice? There's a phonatory category, which is more about the larynx. There's a resonatory, which is about the nasopharynx, and then there's articulatory, which has more to do with the tongue. And it's speaking as a coordination of up to 70 muscles, and you can click ahead a little bit here, Emily. It takes a concerted effort, which is not dissimilar to being sort of a top musician. That much coordination, And it's also done very, very rapidly. So we can make up to 12 sounds per second to make 180 words per minute, which is a sort of a normal speaking rate. And the movements are all very fast, but small, require exquisite control. So it's a window into the motor system that's really unlike other windows. And again, something we've been ignoring with our traditional outcome measures, but we have an opportunity to gain insight into here. Next slide. So for the Answer app, we thought deeply about this, and we've designed 3 different speech tasks. One of these tasks is presented each week. The first one is a picture description. So various pictures show up, and this one, we'd ask people to speak for about a minute, and one might say there's a young man on a stool changing a light bulb, but it looks like he's running into some trouble, and the stool is tipping over, and he's even dropping the light bulb. It's not 100% sure about this, but it looks like his innocent-looking dog may have been the one to precipitate this. And strangely, there's a young woman sitting just a few feet away who's nonplussed. That speech can give us a lot of information about motor speech control and even about some of the word choices that people are making. So that's a really important task, and speech is a little different if we're creating free speech relative to reading. So we wanted to have a reading task as well, and there's a standard passage called the bamboo passage that has a lot of the articulatory sounds and fricatives that are important for understanding speech, and so there's this bamboo passage has been incorporated for the reading passage. And the last one is to really get at respiration as well as speech. And that is what we call the breathing task. But it's counting from 1 up until one runs out of breath, which is a kind of a crude index of vital capacity. So we want to get a sense of whether this works on the phone the way that it does in, say, an emergency department, where we'll sometimes stand at the bedside and have people count just to give us a sense of how they're doing in neurologic diseases, particularly ones that are changing moment by moment, which some diseases can. So I think that'll be exciting to see. Colin Quinn is a colleague who was at UMass for some time and is in Philadelphia now, and did a small study validating that the single breath count task does have some validity relative to vital capacity, and I think that's a very hopeful thing. Next slide. So it also turns out that we carry around very high quality microphones in our pocket with phones. So call quality is not always that good, but that's because the signal is compressed when we send it over the airwaves. But the actual microphone, when we're picking up the recording for an app like this and not transmitting it for phone purposes, but recording it directly onto the device, is very, very high quality. We did some testing here, again, in Jordan Green's lab, comparing his really sophisticated sort of research quality microphones to a smartphone in the same environment. And we, there are all these various aspects of sound that we can look at, jitter and shimmer and median pitch and for example, and really the numbers are almost identical. Next slide. I should say, I just want to add to that it doesn't mean that you shouldn't be in a quiet place while you're making your recording. That still gives us a lot better data. So the Answer app is now deployed. We have it. We roll it out at 2 sites. First, Johns Hopkins and MGH. We have 48 participants enrolled. 70% of those are participating. We chose to roll it out at 2 sites because there's sort of an interface of 2 worlds in this kind of a project. One is the tech world where there's a beta version and another beta version and then the rollout version, and that gets updated, and our apps are updated on an almost daily basis as things get better and better. And the second world is clinical research, where we spend a long time designing a project we really try to get it right, and then we sort of roll it out and try not to change it much while it's going, so that we get comparable data. And we know that those are very different approaches, and we need to marry them. And so we sort of started at these two centers to iron out a few kinks, and now we're rolling this out to all of the Answer ALS sites, and they're in startup process now. The other thing is that this was first designed for the iOS devices. The Android devices the app for Android devices is on its way. So these 48 participants are those with iPhones or iOS devices. So this is exciting, and 48 participants is really it's quite a lot, and we want to grow that number exponentially. Next slide. So IBM Watson is a partner in this, and they've already taken some of the preliminary data and done an interim analysis looking at motor speech control and looking at the reading and the counting tasks. And there is a correlation with disease progression looking at the ALS-FRS-R, and I think we can really kind of improve those analyses and hone them. This was just a very first stab at it. They also did some very sophisticated analysis of vowel space and sort of comparisons of that to a reference range. I won't try to represent the complexities of this detail, except to say that it's just a real joy to work with the folks at the IBM Watson team who are really, just bring a brilliant perspective to all of this. Next slide. So, I guess we want to think for a moment about how, we can go back one slide. We want to think for a moment about how this app fits into the whole Answer ALS ecosystem. So Emily gave a very nice overview at the beginning of this about kind of the whole project. That is creating what we call induced motor neurons. That means we take a blood cell out of blood that we draw. We turn that into a stem cell in a petri dish and then reprogram it to be a motor neuron in a petri dish. And then we send those motor neurons around the country to look at what's called epigenomics, which is sort of changes to the genome that happen throughout life that may impact what genes are turned on or off. Transcriptomics, which is an examination of what genes are turned on and off. Proteomics, which means what proteins are in that cell. Really sophisticated molecular work that's going on. We also send samples to the New York Genome Center, and we look at whole genome sequencing, something that just about 20 years ago cost $1 billion per person. And now, we can do as a part of a project like this on 1,000 people and already be a part of discovering a new ALS gene partway through our project. Really exciting stuff. The fact is that's all mapped back to our clinical data. And so this is, about people with ALS, trying to characterize what's happening with them. And we have traditional data, and we've done what we can to make that very a very sophisticated look at people's state of function. And we'll be able to add to that this really detailed, rich data set from the app so that we can identify clinical variants, maybe new clinical variants, maybe understand progression better. There is a lot to be said for doing that on its own, but we can also use that to map our genetic and molecular discoveries back to what's going on in patient subsets or individual people. And already we're getting hints that is going to be a critical piece of the analytics that we do on a biochemical level. So this data will be immediately helpful in the ecosystem of Answer ALS. Next slide. So, this is a huge project with many sponsors, either funding the project or giving in-kind donations of their expertise. We also have, a huge project management team that's really kind of overseeing the project and allowing us to meet with success. I really can't sort of overstate how important that team aspect is, and it's just been a really can-do team to work with, and I would just say from my perspective, an incredibly exciting project to be a part of. And I think all of our hopes is that we would want people participating in the project to also be energized by all the things that are going to come out of this. So thank you very much. Next slide. We just want to want to take 1 second and thank all of you who are participating or have looked for a way to participate or may participate in the future. That is the driver, the engine that allows any of the science to happen. So never underestimate your contribution to moving the ball forward in this kind of a project. Thank you.
Thanks so much, James. That was really wonderful, and I would reiterate your sentiment. You know, this program really starts and ends with our ALS participants, and we are incredibly grateful.
Now, I have to admit, there's a little problem with my audio, so I'm going to try to fix that and mute myself for just 1 second.
Okay. Great. Thank you so much, James. I just wanted to take a moment to reiterate what you were saying at the end there and just really thank all of our ALS participants, because this is an effort that starts and ends with ALS patients, and we're very grateful to have everybody's time and support in this rather large program. So having given that overview of the program, we would certainly welcome any questions that you may have at this point. I think we have a couple that have already come in. The first is, can the app be used on an iPad or tablet? If we have James back, I don't know if you want to take that, James, or I can answer it. So we currently, the app is just available for a smartphone, and that's really to do more with scaling things. So we have carefully designed these tasks so that you are limited to the area within the phone. And so obviously when you take that to an iPad, it scales up. But we could certainly work with the team to see if that's a viable option for future studies. We had another question about will we be opening additional sites, 8 sites. That is something we would love, of course, to have numerous sites spread across the country. Right now it's a question of money and operating those clinics. So our current 8 sites are doing really a terrific job, as I mentioned, of enrolling. So our budget, unfortunately, leaves us with just those for the moment, but of course we would love to increase that number of sites in the future if we could. Great. And I would mention also that if, as you process all of the information that James gave us today, if you have questions later on, you can certainly submit them to us after the webinar, and we will do our best to reach out to you afterwards and address it. One other question that came through, one of our participants is wondering, how does a PALS get involved with the app project? James, would you like to speak to that?
Yeah, can you hear me, Emily?
Yep, we can.
Great. So the app is really aimed at, right now, we're aiming at people who are in the Answer ALS project. And for those people who are participating at Johns Hopkins and MGH, the project is already up and running. It's in startup at the other sites. So if somebody's participating at one of the other Answer ALS sites, it'll be a matter of time. So the protocol is written. We have the informed consent. That's what you sign before you start in a project like this. And it needs to go through a process of review by the ethics board. So every study that we do always goes through a review by the ethics board. Currently at each institution, there are efforts underway to sort of streamline that process. But so that process is sort of underway. We anticipate that the site soon will be able to enroll people. For right now, we are not enrolling people in the app who are not in the Answer ALS project. But that's also something that we've sort of actively talked about. You know, how do we, how could we expand even beyond the Answer ALS project? Right now, it's really important that we have the traditional outcome measures that we're doing as a part of the Answer ALS project to combine with the digital outcome measures so that we can understand our tools well.
Great, thanks. And sort of along those lines, another attendee asked, is it possible to do this in Europe?
Yes, absolutely. again, because we're focusing on the Answer ALS sites, probably right now we're not going to expand this app to Europe. There are other apps that people are working on, and certainly there's nothing to say this couldn't be done in Europe. There are some complexities of sharing data back and forth that we would just have to be aware of for this kind of a project, but they're all overcomable. And what I would say is that this is the tip of the iceberg. I think for those of us who are kind of doing this, what I see is a burgeoning of interest in this from people with ALS, but people with various diseases, and researchers in many fields, and tech companies and pharmaceutical companies. So there's a huge thrust toward this, both within the ALS world, but also in the broader medical world.
Thanks so much, James. And there's actually a really nice video about the Answer ALS program that our communication team put together, and we don't have time to show it today, but I'm going to leave it in the link at the end of the webinar, and it's also on the Answer ALS website if you want to take a look. But I think for many of us, the Answer ALS program is really about opening the door to the end of ALS, and I think the video captures some of that sentiment, and so take a look if you have a few moments. Other than that, please continue to submit questions, and we will reply as much as we can. I would really like to sincerely thank Dr. Beiwe for his time today and giving us a wonderful overview of the app's development, and to thank everybody for attending and giving us your time today. We really appreciate it, and we are hopeful for the future, and we will keep working on this program because it's one we believe in. Thanks so much, everybody, and thanks, James.
Thank you.